In number 27 in your classwork for simplifying rational expressions, I ask you to simplify the fraction. So we're going to pull out the greatest common factor in the numerator. So we're going to have a x out in front of 4x squared minus 4x minus 15 over pulling out the greatest common factor of x cubed in the denominator. We're left with 2x squared minus 3x minus 5. And now we can factor these further. So in the numerator, factoring 4x minus 4 minus 15. So we want two numbers to expand this middle term into something that multiplies to this 4 times negative 15, which is negative 60, but adds to negative 4. So we can do that with a minus 10 and plus a 6, because minus 10 plus 6 will add to negative 4, then minus 15. So we can group the terms in such a way that we can then factor it. So if I group 4x squared minus 10x together, I can pull out a common 2x. Then I'm left with 2x minus 5. And grouping 6x minus 15. So pulling out a 3, then I'm left with 2x minus 5. So our numerator can be factored fully to x times 2x plus 3 times 2x minus 5. Now we're going to worry about the denominator. So factoring the denominator, we're also going to look for two terms that multiply to this negative 10, which is the product of 2 and negative 5, but add to negative 3. So that occurs when we have a negative 5 and a positive 2. So we can break that middle term up into plus 2 minus 5x minus 5. Grouping this together, we have 2x times x plus 1 minus 5 times x minus 1. So we have a 2x minus 5 times x minus 1 in the denominator. So this is our factored form, and now we can go ahead and cross out like terms. So we can go ahead and get rid of this 2x minus 5, and this x over x cubed simplifies to x squared in the denominator. So overall, we're left with 2x plus 3 over x squared times x minus 1. And we have to remember about our domain restrictions. So one restriction is the term that crossed out. So 2x minus 5 cannot equal 0, meaning that x cannot equal 5 halves. And we also crossed out an x over here. So also in the denominator, x cannot equal 0. So we have two domain restrictions for our expression.